In this problem, there are three vectors k, l and m. K, l and m. You need to find the x and the y components of these vectors. The magnitudes of these vectors are given. We will use these equations to find the x and the y components. Here the angle theta is from the x-axis, from the positive x-axis or from the negative x-axis. Further, the components can be positive or negative. So, you need to put the appropriate sign by looking at the figure. Let us find the components of this vector, k vector. You need to draw a rectangle with the vector as the diagonal. Now this is the x component and this is the y component. So this is kx and this is ky. Now the x component is kx equal to, you need to look at the direction of this vector. This vector points to the positive x direction. So it should be positive. You put a plus sign. For plus sign, you don't have to put the sign. Now put the magnitude. The magnitude of this vector is 15 meter. You put the 15. Now cosine theta. Cosine this angle. So this angle is from the x-axis. Now find cosine 47 and multiply with 15 and round to the correct number of significant figures, you will get this. Now you can put the unit meter. So this is the x component of this vector. Now the y component. Look at the direction of the y component vector. So this points to the positive y direction. So you need to put the plus sign. Now the magnitude, that is 15. This is the y component. So you need to put the sign. Sine 47. This is equal to, you will get 11. Put the unit. So these are the x and the y components of this vector. Now we will find the components of this vector. This vector is along the x-axis. So the y component of this vector is 0. Now the x component is the vector itself. Look at the direction of this vector. This points to the positive x direction. So it is positive. And you need to put the magnitude of this vector. That is 8.0. Put the unit. So these are the x and the y components of this vector. Now this one, you need to draw a rectangle with the vector as the diagonal. Now this is the x component. This is the y component. So this is mx. This is my. Now look at the direction of this vector. This points to the negative x direction. So you need to put a minus sign. Now put the magnitude. The magnitude of this vector is 12 meter. Put the 12. Now put the cosine. So here this angle is from the y-axis. But we need the angle, this theta, from the x-axis. So you need to subtract this angle from 90. 90 minus 30 is 60. So this angle is 60 degrees. You need to use this angle here. This is equal to negative 6.0 for the unit. Now find the y component. The y component points to the negative y direction. So put a minus sign. Now, so for the x component, cosine. For the y component, you need to put the sign. So put this 12, then sine 60. So this is equal to negative 10. Negative 10. Put the unit. So these are the x and the y components of this vector. In this problem, a car travels 15 kilometers due north. Next, it travels 22 kilometers in a direction 25 degrees south of west. Then it travels 9.5 kilometers in a direction 39 degrees north of west. You need to determine how far the car ends up from the starting point and find the direction of the car's displacement. You need to write the direction relative to a standard direction. The car makes 3 displacements, this one, and this one. Let us draw the displacement vectors. First, 15 kilometers due north. North 15 kilometers. Next, 22 kilometers in a direction 25 degrees south of west. First take this. West is here. This side north of west, this side south of west. 25 degrees south of west is this. This angle is 25 degrees. The length of this vector is 22 kilometers. Next, 9.5 kilometers in a direction 39 degrees north of west. Take this. This is west. You need north of west. This side north of west, this side south of west. So 39 degrees north of west is this. This angle is 39 degrees. The length of this vector is 9.5 kilometers. Let us take this vector A, this B, and this C. This is the initial position of the car and this is the final position. Draw a vector from here to here. This is the resultant vector. You need to find the magnitude and the direction of this vector. Next, we need to find the components of these vectors. For that, let us put the vectors on the frame of reference. Vector A, start from the origin. Magnitude of the vector is 15 kilometers. Now this vector, this angle is 25 degrees. Magnitude is 22 kilometers. Now this one, this angle is 39 degrees. Magnitude is 9.5 kilometers. Now let us find the components of these vectors. This vector is along the y-axis, so its x component is 0. Now the y component is the vector itself. This is the y component. This vector points to the positive y direction. This side is positive, this side is negative. This point to the positive y direction. So it is the y component is positive, and you need to put the magnitude. Now for this one, let us draw a rectangle by keeping the vector as the diagonal. Now this is the x component and this is the y component. That is, this is bx, this is by. So bx is equal to, this vector points to the negative x direction. This side is negative, this side positive. This points to the negative x direction. So it is negative. Then put the magnitude. So the x component, so you need to put the cosine of this angle. So this angle is from the x-axis. That is equal to, find cosine 25 and multiply this, you will get this. Now the y component, by, is equal to, this vector is also point to the negative direction, negative y direction. So it is negative, to the magnitude, this is the y component, so you need to put sine of this angle. This is equal to this. Now this vector, draw a rectangle. This is the x component and this is the y component. Cx, cy. Cx is equal to, this vector points to the negative x direction. So you need to put a negative sign. Then the magnitude, x component, so you need to multiply cosine of this angle. This angle is from the x-axis. This is equal to, find cosine 39 and multiply, you will get this. Now the y component, cy, this vector point to the positive y direction, so it is positive. Now put the magnitude, y component, so you need to multiply sine of this angle. This is equal to 5.98. Now make a table and put the vectors a, b, c. Here x component, y component. For the vector a, the x component is 0 and the y component is 15. 0, 15. For the vector b, x component is this and the y component is this. For c, this is the x component and this is the y component. Now we have this table. Next, add all these x components. You will get this. This is the x component of the resultant vector. Likewise, add all the y components. You will get this. This is the y component of the resultant vector. From this, you can find the magnitude of the resultant vector by using this equation. This is equal to, you substitute Rx and Ry, you will get this. This is equal to square root of this. That is 30. After rounding to the correct number of significant figures. Put the unit, that is kilometers. Next unit the direction, that you can find by using this equation. You need to find the theta. So Ry is this, substitute Rx, that is equal to this is equal to this. This is tangent theta. We need the theta. So you need to take the inverse tangent to get the theta. That is equal to, you will get this. This angle is negative because one of the components is negative. Now if you look at this figure, this is the resultant vector. This angle is this. The vector is here. This is west. So this vector is north of west. So the direction of the car's displacement is 23 degrees north of west. So the answers are, for A, this is the answer, and for B, this is the answer.